Welcome back, Taylor Tots. Lucky for all of you, I'm actually able to get a little bit of extra time to actually put up that naming video as I promised. But before I kind of go into naming, I did want to kind of mention that again, naming isn't going to go away. Naming is something that is the backbone of chemistry. Being able to look at a compound formula or name and go back and forth with that is something extremely important, especially for this third quarter. With Unit 5 and 6 being pretty much all rooted in naming in a way, it's extremely important that you are good with naming. So again, maybe take a little time, maybe before I start writing things down, again, like, be honest with yourself. Is this something that you need help with? Is this something that you need more practice with? Is this something that you don't understand? Because moving forward, there's going to be a lot of naming. And again, I hate to see you get stuff wrong just because you can't name. Again, we're going to go over the three types of naming: covalent, ionic, and acidic in this video. I'm going to try to keep it under 15 minutes as always. Let's get started. Now, I think it makes a lot of sense just to immediately start with covalent. Again, a covalent compound is one that is made up of two nonmetals. For example, something like C2O4. Again, I'm just going to check to make sure that you guys can see that. I think that's big enough. You might also have something like N2Cl3. More nonmetals. You might have something like, I don't know, maybe some BC2. And you might have something maybe like, let's just say CO. Something just like that. Again, with these, the big thing with covalence is you are allowed to have prefixes. But with the prefixes, you cannot start with mono. Again, I'm just for the sake of this, I'm just going to rewrite these over here. I'm going to change that one up a little bit. Again, can't start with mono. Again, it's redundant. For example, you wouldn't say that that's 1x. You just wouldn't. You would not say that this is 1x to the first power either. You would just simply say that that is x. And again, keeping that in mind, chemists are the same way. I'm not going to redundantly say that's mono something. So keep that rule in mind and you will be just fine. Okay, it's very, very important that you don't put mono first. You may put mono second. And the world's most famous example of this, which is something you've heard of, is carbon monoxide, which is this one right here. Again, with this one, the mono is right there, and I apologize, I'm going to zoom out just a bit so we can see. Oh, I'm going the wrong way. There we go. The monoxide works, and you notice that I changed the ending to IDE. This occurs every time. Because again, anytime you end with an element, you're going to have an IDE ending, which all these will be. Moving forward, just kind of going through some of these again. This one will be dinitrogen. Please note that the prefix is right there. I did not mess with this ending. It's just dinitrogen. And you're going to get trichloride. Again, there is going to be your IDE ending. Just for the sake of this one, again, you're going to have another dicarbon. And you're going to have tetraoxide. And this one's going to be boron tricarbide. Again, IDE ending. This IDE ending is a little messed up, so I'm just going to redraw it really quickly. But again, that is kind of how you do covalent naming. Again, prefixes are extremely important. Again, you can't start with mono. You just cannot do it. Again, going the other way around hasn't really been a problem, so I'm not really going to address that. You guys have been doing a really, really good job of saying, okay, it's dicarbon, it's going to be C2, and then tetraoxide is O4. So really been good there. Tetra's been the only one that's been getting people being 4. But again, you guys have done a really good job with that. But please, 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 monos only in the middle. You cannot have it at the beginning. Again, carbon monoxide is proof of that, so is carbon dioxide, CO2. And again, prefixes do count. Again, I'm just going to pause for a brief second before I erase some of this and talk about ionics. Now, covalent naming has been going pretty well. And that's a really good thing because there are a good chunk of things that are going to be covalent, of course. But the number one category, as you know, is going to be ionics. Now, ionics, that's going to be a metal plus a non-metal. And I like to think of them having 3 different parts, again, which I have called phase 1, phase 2, and phase 3. Phase 1 ionic naming is simply an S metal and a non-metal, which I'm going to abbreviate NM. P2 is going to be an S block metal with a polyatomic ion. Again, these are on the back of your periodic table. Don't forget about those. Those are on the back of your periodic table. And phase 3, as you know, is a transition metal plus either a non-metal or a polyatomic ion, which I'm going to abbreviate PI right now, just for space. So again, the big thing with phase 3 is you're going to have this transition metal part. Phase 2 is a polyatomic ion, and this one is just, honestly, just a straight up S block metal. The alkali and alkali earth metals, for example, potassium, magnesium, lithium, calcium, rubidium, francium, stuff like that. How to go through naming these. Here, again, with ionics, 2 main things. You are never, ever going to put a prefix. Ever. As a matter of fact, I'm going to zoom in on that. You are never, ever going to put a prefix. Ever. Okay? Never. Never. Do not do it. Again, the prefix part is specifically for covalent compounds, which means if you're putting a prefix with an ionic, it's instantly wrong. There's nothing you can do to fix it. For example, something like tripotassium doesn't make any sense. So again, please, 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 never, ever put a prefix. The second you do, you're instantly wrong. Again, that's the number one mistake that's still been happening, in all honesty. And again, I really don't want to have that occur, okay? Because that means you're done before you even begin. Also, with these as well, you got to make sure you're crisscrossing. You got to make sure you're doing the crisscross at all times. You crisscross every single one of those all the time. And again, that's something that's been getting people. You guys are just forgetting to do the crisscross. Again, that is going to be something that is going to cause you a lot of trouble across the board. So again, ionics always crisscross. Always, always crisscross. Again, I'm just going to erase some stuff. Again, for example, some just small examples of what a P1 could be. You might have something like KCl, or maybe you'll have something like lithium oxide. Something just like that. Again, when you're converting those names over. It's very kind of simplistic in how you do it. That's potassium. And that's chlorine, which becomes chloride. People have done a really good job remembering that IDE ending. Apologize, I almost spelled potassium wrong. Lithium oxide is again Li, and then oxide is oxygen O. But that's not right, because you must crisscross. Li plus 1 with an O minus 2 will become Li2O. And again, you don't have to put that one. I'm going to. And I would recommend for some of you that you do that as well. And again, that's essentially how all those go. Nothing too crazy there. Kind of moving forward with the polyatomic ones. Again, I might have something like Na. You know, let's not even do Na. Let's do something a little bit different. How about we do something like, yeah, you know what? Let's do that. And we're trying to put a hard one up. Na2SO4. Or we might get something like potassium hydroxide. Again, here, as you can see, I do have a polyatomic ion. This guy and that one are polyatomics. This one, Na is sodium. And SO4 is sulfate. So this is just sodium sulfate. This one, again, already going over the crisscross. Potassium's plus 1, hydroxide's minus 1. If you put those two together, you're just going to be at KOH. Again, very kind of first name, last name, very crisscrossing, nothing really to think about there. Again, just to prove that this one works, again, we have a plus 1 with invisible 1, and sulfate is, of course, minus 2. So that one does prove and work out. And then we're left with our transition metal one, phase 3. Now, just for the sake, I am going to erase this part. I'm going to do the phase 3 stuff over here, just for space. And again, I know some people might have already got that down. And again, I'm going to erase this as well. And I'm going to go over here for phase 3. Here, transition metal. Transition metal. We don't know the charge. And because we don't know the charge, we can't automatically assume the crisscross, which is kind of a pain in a little bit. Again, I'm guessing people have this down as well, so I'm going to erase this as well, just because we need more space, because phase 3, again, are the hardest ones. I apologize, this video will probably be a little bit over 15 minutes, but that's okay. With the transition metals, for example, we might have something like this. We might have FeCl4 versus maybe FeCl2. So let's start talking about that first. Well, looking at that, I know that's iron. I know Cl is chloride. Versus here too. But there's something special and different about those two things. It's an iron chloride, but as you can see, the 4 and the 2 do not match. Which again, remember, with these guys, you need Roman numerals. Again, that's going to be your I, your II, your IV, which is 4. People get that one wrong a lot. V, which is 5. Put the 3 in there. Da 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 da. Of course. Now, with this, again, if I were you guys, I just put the parentheses open. Again, every time you have a transition metal, you need parentheses. I would just keep it open right there as a reminder to check. And And again, all we have to do really, if we look at the crisscross, we don't know what iron's charge is. We don't. But we know that there is a 1 from chloride. The chlorine is -1. Again, there's invisible 1s there because of that. And if we know that, and we know there's a 4 here, if you have a -4 charge from your chlorine, again 1, and there's 4 -1s, that's -4 total, how could you balance out a -4 with one thing? Well, it's got to be +4, right? +4 -4 is neutral, IV, or iron 4 chloride. Same thing here. If you have -2 here, how can I balance that out with one thing? It's got to be +2. Which means this is going to be iron 2 chloride. Again, it is a reverse crisscross. I am still crisscrossing. Extremely, 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 extremely important. But again, keep that in mind. You do have to kind of do that little reverse crisscross. Also, that's really the hard part about it. A lot of people are doing really well if I give you the names first. For example, if I give you nickel 3 dichromate. Making something a little bit exotic. Again, I noticed that's a polyatomic ion. It's on the back. I apologize. I chopped off some of it. Again, what I would just simply write down very, very smoothly. Nickel is +3. And dichromate, Cr2O7, is -2. Now, what I would recommend doing, again, don't forget to crisscross, because you are a boss, Rick Ross, barbecue sauce. So I would go Ni2. Again, I will need parentheses because I will be putting a 3 on the outside of that. So again, the answer for nickel 3 dichromate, Ni2, parenthesis Cr2O7, end parenthesis 3. Essentially, there's a plus and a -6 on both sides. And again, that's essentially how all the ionic ones work. As you know, I crisscrossed every single one. There wasn't a single prefix on here, except maybe this one, but that's a polyatomic. That's different. So it's dichromate. That is one thing. Again, that'll make your life a lot easier. Again, I'm just going to pause for a quick second, and then I should be able to talk about acids pretty quickly. And again, I kind of have been doing some harder problems on here just in case, just so you can kind of get comfortable with that. Again, the last thing we need to talk about is acids, and acids are always start with H. Which is hydrogen. Again, acids are an extremely important part of this that a lot of people forget about. There are two types, which are binary and polyatomic. Again, polyatomics have a polyatomic ion, which I will abbreviate Pi again. And binary is just 2 elements total. So this one will always be, again, kind of as an example, H, and there's going to be something else here. I don't know what that something else is, but it's something else here. This one is going to be H, and there's going to be a polyatomic ion there. Also, keep in mind, just like ionic, you crisscross acids every single time without fail. Again, covalent things kind of mess around a little bit. Ionics and acids crisscross every single time. If you do that, again, you will be just fine. With the binaries, again, these are going to look pretty nice. It's going to be, for example, something like HBr, or it'll be kind of the familiarity, hydrogen, hydrochloric acid. Again, please don't forget the word acid. Some of you did that on the homework. It was super bum me out quite a bit because, again, you have it, and then you forget to tell me it's an acid. Again, acids always start with H. So looking at these really quickly, again, this is how all the format works. It's always going to be hydro, something, ic acid. You just kind of have to fill in the blank. That's bromine, so it's bromic. Hydrobromic acid. NaHCl is, again, a hydrogen, of course. And that blank is, this time, chlorine. Chlorine. And again, double checking that crisscross. You have a +1 with a -1. You're good to go. The answer is HCl, which again is an acid we have talked about and you have seen. Again, hydrobromic acid is right here. Here, though, again, you're not going to see that. You're not going to see this hydro at all. Binary is the only one where you're going to have hydro. The absolutely only one that's going to follow this hydro something ic acid piece. Polyatomics are a little bit different. And again, they're going to look something maybe like let's go H3PO4, or it'll be something like nitrous acid. Again, please note, I did just write the word acid. With these, again, nothing too crazy, as long as you remember one little itty bitty thing. The endings for the polyatomics. Again, and I'm going to kind of put it maybe a little bit off to the side here. Okay, so I apologize for this. But again, if it ends with an 8, you know what? I'm going to actually change the color of that so it stands out a bit more to you. If it ends with an 8, it's ic. And it ends with ite, it becomes us. Again, this is something that is extremely important. Because again, if you name it the wrong way, that's going to be kind of a big deal. You're going to be working with two different things. I know that PO4 is phosphate. Which means, if it ends with an 8, this just became phosphoric acid. Because again, the 8 becomes an ic. Again, remember, I ate it and it was icky. For example, like me, peanut butter or chocolate. Like Reese's are absolutely nasty. I hate Reese's. Again, if I ate Reese's, I would consider it icky. Again, with nitrous acid, again, this one has an OUS ending, so you know you're going to be using nitrite, which is NO2. Keep in mind, it always starts with hydrogen, so that's pretty easy. I'll double check the crisscross. H is +1. As it turns out, so is nitrite. So nitrite and hydrogen are +1 and -1, which means the answer for this one is just simply HNO2. Again, in this example, there is a crisscross that is occurring. You have a +1 and a -3. And that's why it's H3PO4. And again, I'm going to zoom in on this just a little bit so you can kind of see it a little bit better. And honestly, that's everything with naming. I know this video was a little bit longer than I kind of wanted it to be, but honestly, I think it's a pretty good summary of how to go over everything. Honestly, the only things I really didn't talk about are what each prefix is, all the Roman numerals, even though I put some down. Again, if you need help with naming, let me know. This is something that I want you to be good at. This is something that, honestly, the course needs you to be good at. So again, if you have any questions or comments, please let me know in class. Post it to the YouTube video, tweet me, do whatever you have to do. And again, please keep in mind, peace road bro. I am wearing my sunglasses. There we go. But again, have a great rest of your weekend. And again, let me know if there's anything I could do to make these videos more helpful. Again, take care. Later.